In some subdivisions, a perplexing issue arises where the activation of an air conditioning or heating system in one home causes the lights to dim in the adjacent house, but not in the house where the HVAC system is running. This phenomenon, occurring in homes with underground electrical services, suggests a problem beyond the typical demand fluctuations. While the power company indicates that their initial checks reveal no issues from their end, several potential causes within the home electrical systems warrant investigation. One possible cause is a miswired neutral connection. A miswired neutral can create a scenario where current from one house inadvertently flows through the adjacent house's lighting circuit, resulting in the observed dimming effect. This occurs because the neutral wire, which is supposed to provide a return path for current, is improperly connected, leading to current imbalances and voltage drops in the neighboring house. Secondly, a grounded fault on one house's electrical system can establish a parallel path for current to flow through the adjacent house's lighting circuit. When a grounded fault occurs, a portion of the electrical current deviates from its intended path and flows through the ground, potentially utilizing the neighboring house's wiring as a return path. This unintended current flow can cause voltage fluctuations and dimming in the affected house. Thirdly, damage to an underground cable connecting the two houses could result in current leakage and voltage fluctuations that affect the adjacent house's lights. Underground cables are susceptible to damage from various sources, including corrosion, physical impact, and environmental factors. If the insulation of an underground cable deteriorates, current can leak into the surrounding soil, creating a path for voltage fluctuations to propagate to nearby houses. Also, nonlinear loads, such as HVAC systems, can generate electrical harmonics that interfere with the voltage and current waveform. These harmonics can cause fluctuations in voltage that affect the lighting in adjacent houses. Electrical harmonics are distortions in the sinusoidal waveform of alternating current electricity. HVAC systems, due to their electronic components and switching mechanisms, can introduce harmonics into the electrical system. These harmonics can propagate through the wiring and cause voltage fluctuations, which can manifest as dimming lights in neighboring houses. Finally, in some cases, the design of the electrical system can create resonance, which amplifies voltage fluctuations and can lead to dimming issues. Electrical resonance occurs when the inductive and capacitive reactances in a circuit are equal, causing the circuit to oscillate at a specific frequency. This resonance can amplify voltage fluctuations, making them more noticeable and leading to dimming issues in adjacent houses. To effectively troubleshoot this issue, several steps should be taken. Firstly, verify neutral wiring. Inspect the neutral connections at the main electrical panels, subpanels, and outlets in both houses. Ensure that the neutral wires are properly connected and not shorted to ground. This involves visually inspecting the connections for any signs of looseness, corrosion, or damage. Use a multimeter to test the continuity of the neutral wires and confirm that they are properly connected to the neutral bus bar in the electrical panel. Secondly, check for grounded faults. Use a handheld electrical tester to check for grounded faults on both houses' electrical systems. If a fault is detected, the faulty circuit should be isolated and repaired. A handheld electrical tester, such as a receptacle tester or a multimeter, can be used to identify grounded faults. The tester will indicate whether there is a connection between the hot wire and the ground wire, which is indicative of a grounded fault. If a fault is detected, a faulty circuit should be isolated by turning off the circuit breaker and then inspected for any signs of damage or insulation failure. Thirdly, inspect underground cables. Contact the utility company to inspect the underground cables connecting the houses. Look for signs of damage, corrosion, or inadequate connections. The utility company has specialized equipment and expertise to inspect underground cables for damage and corrosion. They can also check the connections to ensure that they are properly made and that there is no voltage leakage. Fourthly, measure voltage. Use a voltmeter to measure the voltage at multiple outlets in both houses. Check for significant voltage fluctuations or drops when the HVAC system is in operation. A voltmeter can be used to measure the voltage at different outlets in the houses. The voltage should be within the acceptable range, typically 120 volts. If there are significant voltage fluctuations or drops when the HVAC system is in operation, it could indicate a problem with the electrical system. Fifthly, analyze electrical harmonics. Consider using a power quality analyzer to identify and quantify electrical harmonics. If excessive harmonics are present, mitigation measures may be necessary. A power quality analyzer is a specialized instrument that can measure the levels of electrical harmonics in a circuit. If excessive harmonics are present, mitigation measures may be necessary. These measures may include installing harmonic filters or using equipment that generates fewer harmonics. Sixthly, inspect electrical system design. Check the electrical system design for potential resonance issues. This may involve reviewing the system's impedance and capacitance. The electrical system design should be reviewed by a qualified electrician or engineer to identify any potential resonance issues. This involves analyzing the system's impedance and capacitance to determine if there are any frequencies at which the circuit could resonate.